So 4.2 is similar to what we did in 4.1. So if you are kind of lost from the video that you watched in 4.1, just make sure you pay attention today and it might answer some of your questions. 4.2, we're going to talk about the number E. So E is just a button in your calculator. This page talks about like where it comes from, but you don't really need to know the history of E. Just know that it is a button in your calculator. E is about 2.718. It keeps going. You don't have to memorize this. Just put it in your calculator. It's similar to pi, where like pi is 3.14 and it keeps going forever. E is just a value. So make sure you know where it is in your calculator and how to use it. So we're going to be dealing with E as our base to an exponential function. So we'll have E to some power. Looking at example 1, we're just going to practice putting this into our calculator. So every calculator is different, so make sure you know how to use your calculator. So we have E to the power of 3. So here I have a button in my calculator that's E to the power of x. So I have to click second, the E to the power of x button, and then I would click 3 and then equals. And then you should get 20.0855. It says round to 5 decimal places. So when it goes 3, 6, the 6 would tell us to round up to 4. For B, when we do this, you can put it all into the calculator at once. Just make sure you know how to use your calculator. So I'm going to do it in 2 steps. I'm going to do the exponent first, so E to the power of negative 0.53. Now when you put this into the calculator, there's a difference between a negative button and the minus button. If you click minus, it'll tell you error. So just be careful with that. So E to the power of negative 0.53. That'll give you 0.58864. It keeps going, but then I'm going to do the last step and multiply it by 2. So when we multiply it by 2, we get 1.177209. So 09 tells us to round to 1. All right, and then lastly, let's do C. So we're going to do E to the power of 4.8, which should give you 121.510417, which rounds to 2. All right, example 3, we're going to do A. It says how many infected people are there initially? So at time equals 0. So we would just plug 0 into the T. So we're going to plug 0 in here, and then we can put it into our calculator. What's negative 0.97 times 0? 0, awesome. Then we have to do E to the power of 0. What's E to the power of 0? 1, awesome. Do it in your calculator, see what you get. You get 1. Then what's 1 times 1,245? 1,245, perfect. So then we have 5 plus 1,245. So 5 plus 1,245 would be 1,250. And then we can divide. So 10,000 divided by 1,250. So we get 8. So when our time is equal to 0, we have 8. Now in B, it says how many people were infected after 1 day. So what would T be after 1 day? 1. What about 2 days? What would T be? 2. And then 5 days, what's T? 5. So you just plug in each one of these numbers into your T, put it in the calculator, and work it out. So make sure you follow your order of operations. Make sure you know how to use your calculator. All right, so next we're going to talk about compounded interest. We talked about compounded interest a little bit in 4.1. In 4.1, we had our compounded interest question or formula was P times 1 plus R over N to the power of N times T. These formulas we're going to give you on the quiz on Friday. You don't have to memorize them. You just need to know what to do with them. So this formula we used when we had a certain amount of times that it was being compounded. So it would say a keyword like daily, and n is however many times that happens in a year. So how many days are in a year? 365. What about if it was compounded weekly? How many weeks are in a year? 52. Perfect. What about if it was compounded monthly? N would be 12. What about if it was compounded quarterly? N would be 4. Perfect, because there's 4 quarters in a year. What about if it was compounded semi-annually? 2. N would be 2. And if it was compounded annually? N would be 1. So these are the most common ones that you'll see. I talked about this in 4.1 notes. So this is the formula for 4.1. It'll tell you if it's compounded. It'll say it's compounded weekly. Then you know that you're plugging in 52 into your N. Now the other types, this is 4.1. The other type is if it's compounded continuously. So if you see the word continuously, we're going to use a different formula. So continuously is not really a set amount that is like per year. So we use a different formula. That's our formula with the E. So it's our PERT formula. So P is going to be the principal. That's our starting amount. R is the interest rate per year. So R is going to be the decimal version of the percent. So if we have 50%, what do you think the decimal version of that is? 0.5, perfect. What if we had 6%? What's the decimal version of that?
0.06.
So 0.06. What if we had 3.5? What's the decimal version of that? 0.035, perfect. So you just move the decimal 2 places to the left, or divide your percent by 100. So for the rate, it's always the decimal version. And then T is going to be the number of years, so T just talks about time. All right, let's look at example 4. We want to find the amount after 3 years if $1,000 is invested at an interest rate of 12% per year, compounded continuously. So continuously tells us that we're going to use our PERT formula. So our amount is going to be equal to P times E to the power of RT. So P is our starting amount. What amount do we start with? 1,000. E is just a button in our calculator. R is the decimal version of the percent. What's the decimal version of 12%? 0.12, perfect. And then T is time. How many years are we talking about? 3 years. So when we plug that in, we have 1,000 times E to the power of R, which is 0.12, times 3. So when we put this into the calculator, make sure you follow your order of operations. We have to do the exponent first. So 3 times 0.12 would be 0.36. So we have 1,000 times E to the power of 0.36. So I'm going to do E to the power of 0.36 next. So that would be 1,000 times 1.4333. It keeps going, but we're just going to leave it in the calculator. Last step is we're going to multiply it by 1,000. So we get 1,433.329. So that would round to 33. Whenever we're talking about money, round to 2 decimal places. So money is always going to be 2 decimal places. It probably won't tell you on the WebAssign or on the quiz what to round to when you're talking about money, because it's just going to assume you know money is 2 decimal places. and invest at an interest rate of 5.35% for 6 years. Find the amount when your interest is compounded continuously. So continuously, we use our PERT formula. So what's our P? What's our starting amount? 13,575. E is just a button in our calculator. What's our R? What's the decimal version of our percent? Move the decimal 2 places to the left. What would our R be? Javi, what's R?
Oh, does that say 5.35?
5.35. So what would
so
R?
0.0535.
Awesome. So 0.0535. So we just move the decimal 2 places to the left. So it'd be 0.0535. And then what's T? 6. Awesome. Let's plug it in. So we have 13,575 times e to the power of 0.0535 times 6. So I would always do the exponent first. Now you could put it all into the calculator at once, but just be careful if you do that. Make sure you know how to use your calculator. So when we do the exponent, it'd be 0.0535 times 6. So we got, you should get 0.321. Now we're going to do e to the power of 0.321. That should give you 1.3785. It keeps going, but we're going to leave it in the calculator and then multiply it in our last step by 13,575. So that should give us 18,713.21. Since we're talking about money, we round to 2 decimal places. So with number 4, this is kind of 4.1. If it's compounded anything other than continuously, we use our formula P times 1 plus R over N to the power of N times T. So P, R, and T are the same thing that we just had in the last question. P is our starting amount, 13,575. R is the decimal version of our rate, so 0.0535. T from before we said was 6. Now what's N? If it's compounded quarterly, what would our N be? 4. Awesome, because we have 4 quarters in a year. So let's plug everything in. We have 13,575 times 1 plus R is 0.0535 over 4 to the power of 4 times 6. So just be careful how you put it in the calculator. I always like to do the exponent first. Let's get this out of the way. 4 times, bless you, 4 times 6 would be 24. So our exponent's 24. Then I'm going to do inside the parentheses next. So I'm going to do 0.0535 divided by 4 plus 1 gives us 1.013375. That's the power of 24. So I have a little up button in my calculator, that little up arrow, that I can do the exponent. So I'm going to raise it to the power of 24. That gives us 1.37557. It keeps going, but I'm going to leave it in the calculator and then just multiply it in the last step. So times 13,575. That should give you 18,673.438. So 8 tells us we round up to 0.44. So this would be our answer. For number 5, if it's compounded daily, what would n be? How many days are in a year? 365. So you do the same thing, but your n changes. So your n would be 365. So just pay attention to the wording in the question. If it says continuously, you're going to use the per formula. If it says anything other than continuously, use the other formula from 4.1. Now, 1, 2, and 3 are similar to homework questions, so I'll let you guys just work on the web assign. Ask me questions if you have questions from the homework.